Good morning students, welcome to Narayana live session classes. Today we are going to discuss the assignment of 9th class under the topic work power energy. Let us see the first question here. The first question, two charges of magnitude 10 to the power of minus 19 coulombs, each are separated by a distance 2 meters in free space. If the distance between charges is increased by 4 meters, then the ratio of electric power potential energy is, right? Now, let us go for the solution here. When you go for the solution, the two charges, that is Q1 which is equals to Q2, why? Because the magnitudes are not changed, the distance to the power of minus 19 coulombs, okay? And initially the Q1 charge and Q2 charge are separated by a distance R1 is equals to 2 meters, right? Then the Q1 charge and Q2 charge are separated by a distance R2 is equals to 4 meters, okay? So, now we need to find the ratio of the potential, electric potential energies when compared to first instant and in the second instant, right? Now here for the finding the ratio of potential energy, the potential energy U is equals to the electric potential energy 1 by 4 pi epsilon naught into Q1 Q2 by R, okay? So as you can see here, the 1 by 4 pi epsilon naught is a constant. Q1, Q2 is also made constant, right? They are not changed the charges. So here, the only thing variable here is the distance between the two charges. So the potential energy is inversely proportional to distance. That means U1 by U2 should be equal to 1 by R1 by 1 by R2, which is equals to R2 by R1. Now you know what is R2? R2 is 4 meters and R1 is 2, which is equals to 2 by 1. So U1 by U2 is equals to 2 by 1 and the potential energies are in the ratio 2:1. Okay? So the answer would be 2:1. Right? Now let us go to the second question. The charges minus Q, capital Q and minus Q are placed along x-axis at x equal to 0, x equal to A and x equal to 2A. If the potential energy of the system is 0, then the ratio of capital Q charge and small q charge is, now solution of it, if this is the x-axis, three charges are there. Charge 1 Q1, which is equals to minus Q, is kept at x equal to 0. Q2, which is equals to capital Q, which is kept at a distance A, and Q3, which is equals to minus Q, it is kept at a distance 2A, right? So here the distance between Q1 and Q2 charge, that is R12, is equals to A minus 0, which is equals to A, and the distance between Q2 charge and Q3 charge, that is R23, which is 2A minus A, which is equals to A, and the distance between first charge and third charge, that is R31, is equals to 2A minus 0, that is 2. Okay. Now, in the question they have said that potential energy of the system is 0. That is, the total potential energy is equals to 0. But the total potential energy is the interaction between the charges, that is U12, U23 and U31. That is potential energy when first two charges are interacted, plus the potential energy when the second and third charges are interacted, and the potential energy when third and first charges interact. Okay. Now U12 is 1 by 4 pi epsilon naught into Q1 Q2 by R12. U23 1 by 4 pi epsilon naught into Q2 Q3 by R23, and U31 is equals to 1 by 4 pi epsilon naught Q3 into Q1 by R31. Okay. Now when you add these three, that is U12 plus U23 plus U31 should be equal to 0, because it is given in the question, right? Now 1 by 4 pi epsilon naught of Q1 Q2 by R12 plus Q2 Q3 by R23 plus Q3 Q1 by R31 should be equal to 0, right? Now 1 by 4 pi epsilon naught cannot be equal to 0, so this total term should be equal to 0. So Q1 is nothing but minus Q, Q2 is capital Q, by R12 is A, plus Q2 is nothing but capital Q, Q3 is minus Q, by A, R23 is A, plus minus Q into minus Q by 2A is equals to 0, right? Now this can be minus Q by A minus QQ by A plus Q square by 2A is equals to 0. So finally you will get Q square by 2A is equals to 2 small q into capital Q by A. Okay, this Q and square, A and A gets cancelled, so you will get small q is equals to 4 into capital Q. They are asking the ratio of capital Q into small q, so capital Q by small q is equals to 1 by 4. Okay, so the ratio of capital Q is to small q is equals to 1:4. Okay, so the answer would be 1:4, right? Now let us go to the next question, right? The third question is, two bodies of equal masses move with uniform velocities v is equals to v and 2v respectively. Then ratio of their kinetic energy respectively is, now in the solution they have given two bodies of equal masses, that is mass of body 1 is equals to mass of body 2, let us say that is m. But the velocities, that is first body is moving with velocity v and second body is moving with velocity 2v. Okay, And we know that kinetic energy is equals to half m v square. Now here half is a constant and m, they said that they are equal. So the kinetic energy is directly depending on square of the velocities. So the ratio of kinetic energy of first body to the ratio of kinetic energy second body will be equal to v1 square by v2 square, right? So which is equals to v square by 2v whole square, that is v square by 4v square, v square gets cancelled, 1 by 4. So the kinetic energy 1 by kinetic energy 2 is equals to 1 by 4. The ratio of kinetic energies of first body to the kinetic energy of second body is 1:4. Okay? 1:4. Right? Now, let us go to the fourth question. A 50 gram mass has a velocity of 2I plus 6j meter per second at a certain instant. Its kinetic energy is, right? Solution. Mass of the body is given as 150 grams. When we convert it into grams, that is EJS unit, to SI units, it will be 150 by 1000 kg. And here the velocity are given in terms of 2I plus 6j, vector form, meter per second. So the magnitude of velocity v is equals to under root 2 square plus 6 square, which is equals to under root 4 plus 36, which is equals to root 40 meter per second. And the kinetic energy is equals to half m v square, that is half into 150 by 1000 into root 40 square. So the 0 root and square gets cancelled. So we will be remaining with 1 by 2 into 15 by 100 into 40, 0, 5 2s are 5 3s are 2 1s are 2 1s are. So answer is 3 joules. So the kinetic energy of the body is 3 joules at an instant. Okay? Right. Let us go to the fifth question. A body starts from rest and is acted on by a constant force. The ratio of kinetic energy gained in first 5 seconds to that gained in next 5 seconds is, right? There is a solution here. So they say that the body starts from rest. Now from rest u1 equal to 0, right? Then they say constant force, that is force is constant. Now we know that force is equals to mass into acceleration. Then A is equals to F by m. Now force is constant, mass is constant, so here acceleration is also constant. Now why I am taking acceleration as constant and why I am speaking about it is why, because when the acceleration is constant we can apply equation of motion. Okay, so we can apply equation of motion. So let us apply first equation of motion. V is equals to u plus at. So we know u1, we need to find v1. So v1 should be equal to u1 plus at1, right? Now t1, the kinetic energy gained in first 5 seconds. So here t1 is given as 5 seconds, right? So u1 will be 0 plus f by m into 5. since T1 is given as 5 seconds. Okay, so finally V1 will be equal to 5f by m. Okay, right. Now let us go to the question and see it out. The ratio of kinetic energy gained in first 5 seconds to that gained in next 5 seconds. That is a body starting from here, from the rest at this position, let us say in 5 seconds. Okay, it has some v1 velocities. From here again we have to calculate such that the final is v2 velocity. Now for the second instance, let us say u2 is initial, which is equals to final velocity of first instant. Okay, so here now v2 is equals to u2, so u2 is equals to v1, which is equals to 5f by m. u2 is equals to v1, which is equals to 5f by m. Right, now we have to find v2, which is equals to u2 plus at2. Now the t2 is next to 5 seconds, so here t2 is given as 5 seconds. So I will write v2 as, what is u2? 5f by m, plus what is a f by m, and what is t2? 5. So it will be equal to 10f by m. Right? Now let us find the ratio of kinetic energies. Now generally kinetic energy is equals to change in kinetic energy or gain in kinetic energy is equals to half m v square minus u square. Here we are talking about the same body, so the mass will be constant. So here the change in kinetic energy is proportional to v square minus u square. That is, if I take the change in kinetic energy of first body to the change in kinetic energy of second body will be equal to v1 square minus u1 square by v2 square minus u2 square, which is equals to 5f by m whole square minus 0 square by 10f by m whole square minus 5f by m whole square. Now which is equals to 25f by f square by m square by 100 f square by m square minus 25 f square by m square. Okay. Now here, let me take the other slide here. Right. That is the other slide for the calculations. Okay. Now here, f square by m square is there. So finally we got the change in kinetic energy of first body to the change in kinetic energy of second body is equals to 25 f square by m square by 100 f square by m square minus 25 f square by m square. Now 100 f square by m square minus 25 f square by m square will be 75. So 25 f square by m square by 75 f square by m square. Now f square by m square, f square by m square gets cancelled. So it will be equal to 25 by 75, which will be equal to 1 by 3. So the final kinetic energy, so change in kinetic energy 1 is to change in kinetic energy 2 will be in the ratio 1 is to 3. So here our answer would be 1 is to 3. Right? So you can refer that in the next page here. Right? Okay, students. Thank you, everyone. This was a